In number 11 in chapter 3, it reads, the magnetic field at the center of a 1 centimeter diameter loop is 2.5. In part A, it asks, what is the current in the loop? In B, it asks, a long straight wire carries the same current you found in part A, and at what distance from the wire is the magnetic field equal to the part A 2.5? So if we start off in part A, we know that the radius, because it's a 1 centimeter diameter ring, the radius is going to equal 0.005 meters. And we know that the magnetic field of a ring equals mu naught times the current times 2 over the radius, which will give us 4 pi times 10 to the negative 7th times our current, which we're finding, over 2 times 0.005. And this equals our 2.5, but it's milli, so it's 10 to the negative 3rd. So 2.5 times 10 to the negative 3rd. So if we solve this out, it'll end up being 2.5 times 10 to the negative 3rd times 2 times 0.005 over 4 pi times 10 to the negative 7th. And this will ultimately give us our current, which will then be 20 amps. So now, with this current, we need to find a long straight wire with the same current and the same magnetic field, and we want to find the distance. So we can find the distance with the equation for a line's magnetic field, which is similar to the ring, except for this is equivalent to our distance. This is the distance from the center, so that's the radius. And so in the line, it's just mu naught times the current times 2 pi h equals our magnetic field. We can draw the wire here, and we know that the current is 20 amps, so we know it's here. And we want our distance to be somewhere up here. So this is our distance. And our magnetic field out here is going to be, if we do the right-hand rule, we have our thumb in the direction of the current, and so we know that the current is going to be coming straight at us. So we'll draw some dots up there. So if we solve for this, this is 4 pi times 10 to the negative 7th times our current, which is 20, over 2 pi h equals our magnetic field, which is again 2.5 times 10 to the negative 3rd. So if we solve this, it'll be 2.5 times 10 to the negative 3rd times 2 pi over 4 pi times 10 to the negative 7th times 20 equals 1 over h. So then we just have to inverse this in order to get it. So then h equals 4 pi times 10 to the negative 7th times 20 over 2.5 times 10 to the negative 3rd times 2 pi. And this will ultimately give us 1.6 times 10 to the negative 3rd meters. So that's it for problem 11. Pretty easy, you just have to start off with the ring and knowing the equation for your ring, and then again plugging in our current from the ring into the equation for the line.